Hey, thanks for joining me in this tutorial where we will be building this kind of table that you see here on the screen. And I know that some of you may hate to see the result of what we are going to do just before we start. But yeah, it's, I think, important to realize the complexity involved, and maybe you're just too advanced for something like this and you can then just skip over. But I think this is a great example if you're a beginner to be introduced into 3D configurators. And you see here that we have width, length, height, and thickness sliders that we've just built in HTML, and we can drag them, and you see that the table adapts. We can change the length, the width, the height, the table just adapts parametrically immediately, and we can even change stuff like thickness and make it really thin if we want to. So this is quite a nice and simple example, and it will involve some coding. We will use Rete first in the first tutorial, then we will use Blockly as well to create the same exact result, and we will then use TypeScript as a third option, and these will be 3 different tutorials. So what I'm going to do is I'm going to start with the case that we had in the first tutorial. So we ended up with this sort of cube, that was filleted, and we had some JavaScript here, and you were able to change the size, and we also had some small HTML in here as well. So I'm going to just continue and adapt this code to a new situation. I'm not going to type everything from scratch, but you will be able to see how to do that, and I will go and explain things along the way. So let's get started with creating those inputs for HTML. And maybe first I will just remove this inline script that, it will be broken just pretty soon. So let's not use it anymore. And okay, so let's start with this HTML. First thing that I want to do is I want to put the label beneath here like this. So this will give us the number first, and you will see in a moment why I did that. So first thing is I'm going to change this type of number, which gives us the arrows, to the type of range. And this just adapts our input into draggable slider. Okay, so let's get started, and let's call this property width. Let's say that this is for width, and this is called width as well. So our HTML adapted, and the minimum value for width will be 0.3, the maximum will be 3, and the step will be 0.1. So we will be incrementing the value when we drag along by 0.1. And also another thing that we will do is just to avoid passing text value into the change size function, we will make it a number. So this just makes that into a type of number. Now another thing that we will do is we will go ahead and change this JavaScript for change size, and we will rename it to change model, and you will see why. Basically, the idea is that we want to send multiple inputs in one go. So previously we just did one, right? But now we want to say that we have a constant called model, and it will be having width property, and the default width will be 0.5 maybe, or let's make it 1. Length will be 1. Height will be 0.5. And let's make thickness to 0.05, for example. Okay, so it's in meters, right? So it will be 1 meter width, 1 meter length, height will be 0.5 meter, and the thickness of the table will be 5 centimeters. So this is quite okay. Now we want to also change this function from change size to change model. And that is just to indicate that we're not only changing size now, we will also be changing the model itself. So change model. And what we will be getting from the HTML side is the value and the name property. So the name we did forget here. I will say that we will be sending width as well. And this way we can say that if value, So there will be few situations, right? So if value is undefined or model name is not equal to value that is being passed, then we want to execute the script. So here what we want to do is say if value is not undefined, then we will say that model name is value. So we are assigning a new value to our model, and our model properties are here, right? So name width will change the width property. This is, if you're not familiar with the syntax, that just picks up the property from this object, right? And this, in the case of width, will be width, and in the case of length, it will be length, and so forth. So if value is not undefined, then we will change the model. And for the rest, this can just go further, and we can pass the whole model into this execute script function. And then these things that existed here, they will only need to be adapted as well here. And in this case, we will not be using cube mesh as the result output. We will be using property table. So this table property we will be receiving from our read script or from Blockly script. Okay, so this part is now correct. You know, first time it will call the change model immediately with just undefined value, and that will make sure that we execute the script with default model, right? So nothing will be changed, but yeah, we will use the model and execute the script. The previous mesh will get attached to the table. Another thing we have to do is assign the change model to window change model. And I think we're ready to go further into our HTML. And now we can go ahead and just create other inputs. The only thing I need to do is I need to wrap this into a div, and that is just gonna give us good breaking. And let's now go ahead here and say length. And here we're sending length as well, and here length, and let's do length as well, like this. So the value will be 1, 1. And another thing that we will do is height, right? So height. It's quite important to get these names right, otherwise, you know, this will not work. Ooh, height. So the height maximum value will be, I think, 1.5 or something, and the value itself will be 0.5. And let's keep the minimum to 0.3, that's fine. And the step will be 0.1 as well, that's also fine. And another property that we have here is thickness, right? So the table thickness, ID will be thickness, 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 thickness. Okay, and the thickness, so the default value, remember, was 0.05, the minimum 0.01, the maximum value for thickness, yeah, I think it's something like 0.3 or 25 maybe ish, and the step should be 0.1, like that. So this will give us a good result. So now we set up the GUI, right, the graphical user interface, really fast. It's not very complex or anything, but all of these inputs will call change model function that exists on the window object, and we will be sending the value of that input into it, and this name will indicate the JavaScript which property of a model we want to update if the value is defined indeed. Okay, so we are now finished with the JavaScript, we're finished with HTML. The only thing we may also want to do is just to add here maybe h1 header for saying that this is our table or 3D table configurator, and the setup is now ready. Okay, so let's get started. Let's go to the Rete editor. We'll hit the right mouse button. We will type skybox first, so we will enable the skybox, and that's our skybox in 3D, right? So you don't feel it very well, but you see that the sun is moving. Another thing we'll do, we will create a directional light, and that will create our shadows. We'll take and make the intensity 3. And now we will go ahead and just get the runner input values. So we have, if you remember, width, right? We have length, we have height, and we have thickness. So now what we will do is a similar thing that we did in Blockly. We used a sort of gate. So when we are in Rete editor, we want to use this number slider. And when we will be in runner, we will be using the inputs. So now I'll just create a number slider for each of the inputs. And I'll use the logic gate that is called first defined value gate. And this gate just outputs the first value that is defined. So in the context of read, this number slider will be defined. And in the context of StackBlitz, for example, when we run our script, this will be defined. So that will be outputted. And now if I just use this preview data component, you'll see that we have number 5 here. And if I drag the slider, it gets picked up and passed along. And that is due to the fact that the width is just undefined. Okay, so let's do this same thing for all of the values. Let's go and really fast copy paste this component. Okay, and the last one for thickness. Like that. Okay, great. I will go and I will change these values. So the minimum we have to match what we had in JavaScript. So for the width, the maximum will be 3 and the step will be 0.1. That's fine. And let's put the default value on 1. The length is the same, so 0.3 is the minimum, 3 meters is the maximum, and the step is every 10 centimeters. And let's put it on 1.5. Here the height will be between 0.3 as well, and then 1.5, and we'll increment by 0.1, and I'll put the height of the table on the default of 0.5. And the thickness, that's a smaller value, right? So we go from 0.01 to something like 0.25, and in the increments of 0.1, like that. Now we have the input set up, and I will just create a grid component. So draw grid mesh in order for us to orient ourselves better in this 3D environment. And I will also create a OCCT. So we go here to OCCT category, shapes, solid, and a box. So this will be our tabletop. And we will start by configuring this tabletop. Basically, the idea is that the tabletop width and length should be matching the width and length that comes from our inputs, and then the height will be the thickness, right? So the tabletop height should be the thickness. The only thing is that this isn't picked up correctly, so now it is. And let's move the slider on 0.05 as we had in JavaScript. So now we have our tabletop, but you see that the tabletop sits in the middle of this coordinate system, and what we want to do is move it upwards. But we will need to compute the value first. So let's do that. Let's first create the vector x, y, z. And you see that we can plug it into the center. And we can change, for example, this value to 1. And then the tabletop rises. So now let's compute that y coordinate for the tabletop. So we will use this math category. And we will use 2 number operations. We will go ahead and for the first value, we'll use the height. We will subtract, but we need to subtract half of the thickness. That will give us a good coordinate for this height indicator. And let's do that. So first, let's go ahead and again copy paste this 2 number operation. Let's see that we will be dividing by 2, and let's put thickness here. And now let's move that value here, and this goes now into y. Okay, so now currently this tabletop is 0.5 meter risen, and you can see that if I change the height, this will be moving upwards. If I change the length, it will change as well. And if I change the thickness, this will also work. So now we have this tabletop setup, and let's get started by creating legs. So for the leg, this is quite a bit different, right? What we will do is we will first create a rectangle. So let's create it, rectangle wire. So here we also need to compute few values, and I'll do that by using this toNumber operation. And what I will do is I will subtract the width from the thickness that we get, and that will be the width of our rectangle for legs. And I'll do the same here. So I'll do the length subtracted by thickness, and that will be the length for our rectangle. So let's now plug those into here. Okay, now that's done. So let's maybe also move that around a little like this. So we have a rectangle, and now we will go ahead and get the corner points. So let's type corner point of edges for shape. This is the component we want to use. And now we have our center points for legs. That's fine. Let's hide this component. We don't need it anymore. Now let's create one leg, right? So let's create a box again, and I'll use create box command here. So the width of the leg is actually the thickness that we get from the user, like this, and the length is also the width, and the height is of course the height minus thickness, right? So that's our leg height, and we don't have that value yet. Let's create it. So we will use this number operation. We will subtract, and we will use thickness for the second operation. So let's plug it in now into this height, and now you see that this box is also in the middle of the coordinate system, so we have to move it a little in a different direction. So first thing we'll do is we will lift this leg a little bit upward by the half of the length of the leg, and then we will adapt it to those 4 points. First things first, let's create the vector, what we did here. So let's copy paste it. Then let's create another toNumber operation, and let's divide it by 2. So divide, we just need half of the leg length, right? And we'll use that for the coordinate of y, and that will move our leg upwards to the right location. So if our table would have only one leg, this would be it. It would be fine. But what we want to do is move this leg to these points, right? So let's go ahead and do that now. So I will use a translation component like this, and we will go ahead and say that what we want to translate is the shape, and we will use these corners as input for translation. The only thing that we need to do is flatten the list. So if you don't understand what this does, we can use again the preview data component 2 times now. So let's check what the corners component gives us, and let's check what this component does. So you see that here we had 3 levels of nested arrays, and here we have just 2. And if I increase this, then you will just get the flat number list, but we don't need it. We do need it like this, so that this component would execute multiple times for each of the items that we provide. And let's do that. Let's go ahead and put the translation here, and voila, we have our table set up. Now the only thing that we are left to do is hide geometries that are really not needed for us. So the corner points, also those vectors, have to be hidden, and we can play around with these input values that we have here. So we see that the table adapts, and it looks quite nice. Now we will go ahead and create the ground. So for the ground we'll use circle face, and we'll see that its radius is 2, and that will be enough for us. Another thing we'll go ahead and implement is we will create a compound shape for all of the items we have here. We want to create one mesh and output that as a table to JavaScript. So let's do it. Let's create a list. And let's add these translated elements into the list. Let's add this circle into the list. And of course, we need to find our tabletop that is here and add that as well into the list. And now we provide this list into this compound shape. Ooh, yeah, that's the wrong component. So let's go ahead and type compound again. And we need to use this one, compound.makeCompound. And this expects us to give us shapes. Okay, and now we can also go ahead and hide all of these elements. So whatever we produced in these components we can hide, because compound shape is now being drawn. And look, now if I hide the compound, you know, everything is hidden. That's what we want to achieve here. Another thing that we will do is we will draw any async component. We'll pass this as an entity to it. We'll create shape simple options for drawing this entity, and here we can change the color. So let's do that. Let's use something like this maybe. I'll also make the edges a bit thinner, so maybe 1. And we want to also hide the compound shape, so to see the effect of that. Okay, now we have our final result, and we have to output that as a table to the runner. So we will use this component, set runner result value. We'll see that the property is called a table, and this is the mesh output that we want to provide to it, and we're good to go. So I just cleaned up the draw grid command, and I can go ahead and export this script to runner. I'll minify it so that it doesn't take that much space in here, and I'll paste it here in this return. And now, if all is good, you see that we've got our table. We can adjust the camera and then, of course, play around with these inputs. And you see that they are being picked up. So I did not mess up the naming of these inputs. Everything is working as expected. And yeah, that's a short tutorial in Rete that shows you how you can go and create a small parametric table. I know this is not a very complex model, but it is illustrating quite a lot of things that, you know, in practice you will definitely need. So things like inputs, outputs, whatever is happening here is also quite important. So I hope you enjoyed this tutorial, and let's see each other in the next ones where we code the same table in Blockly. So cheers.